Hey, hello, students. I got a question here about chapter 7 and the homework, number 10 in particular. So let me give that one a try here. It says a toy car has a kinetic energy of 12 joules. What is the kinetic energy after a frictional force of zero point 0.8 newtons acts on it for 4 meters? Okay, now the idea of this chapter is the principle of conservation of energy. So let me make a double chart. You saw me doing this also or I should say a chart with two columns. I was doing this for momentum, but I want to extend this to you that this has to do with also energy and angular momentum, okay? And the energy one here is to say if you take up all the energies before, it has to equal to all the energies after. All right, so in this problem, they just say that there is some kinetic energy. So I'll say initial kinetic energy equals. And they actually give a number. They say that the toy car has a kinetic energy of 12 joules. Okay. So that's the initial, or maybe to match it with last chapter, what I say before and after. Okay, so before anything happens, before there's the friction, we've got this 12 joules. So then afterwards, what's going to happen is there's going to be some kinetic energy final. And then there is going to be some heat that's created. This is the work done by the friction. This is the force times distance, okay? And so that's what we've got to put together, that the heat is the work done by friction and work is force times distance. Okay, so I'll put here kinetic energy final. And then say, okay, well, then what is the heat? And so they say the force is 0.8 newtons, okay? And acting on it for a distance of 4 meters. And if I continue on with my math, 4 times 8 is 32 with a decimal, so 3.2, and a newton times a meter is a joule. And so now if I move that to the other side, I can get the answer here, which is what is the final kinetic energy? Let's see, 9 take away 3, or 12 take away 3 is 9, and so we're down to 8.8 joules. And so there would be the answer.